everybody, Mrs. Poole here again with the next lesson that we have for you today. I guess I was on the wrong slide. Here we go, engineering and design process. The last time we talked a little bit about what the scientific method is. Do you know what the difference between a scientist and an engineer is? Try to create or invent something or a solution to a problem that they might have. They might think that Tide is a better detergent than Gain, so they are trying to prove a theory. Now, engineers, they try to solve a problem. Usually that involves inventing something or creating something. So there's all kinds of engineers. There's computer engineers, there's civil engineers, there's mechanical engineers, there's chemical engineers, there's biochem engineers, biology engineers, there's genetic engineers, there are, I can't, computer, what did I say that already? There's a ton of different engineers. In fact, I would dare to bet that the majority of you guys in this class who are going to pursue science as a career will end up in some sort of engineering field. So with that being said, here's what we're going to be doing. Again, you're taking notes. This is the title that goes at the top of your notes, and you guys pause whenever you need to catch up. So today's lesson objectives are to learn the difference between scientific method and the engineering process, and then to also correctly identify the criteria and constraints of a problem. Okay, what are the constraints and the criteria that engineers have to deal with? Comparing engineering and scientific method. There we go. Now this looks kind of daunting, all of this, but go ahead, put your Roman numeral number 1, subtitle, and then go ahead and just indent. You don't need to have this box. Basically, I tell you what each of the different types of science are, and then I give you an example. So scientific method is what just like I said earlier, that the scientist sets out to prove a theory by designing some experiments that have, well thought out variables, and they are careful to make sure that they have a control and that they're have a valid experiment, all those things that we talked about in the last class. So setting out to prove a theory, okay, by experimentation. So an example of that might be asking which detergent works best, like I said, Tide, Kirkland, Gain, and then they design an experiment to go about and prove what their hypothesis is. Maybe their hypothesis is wrong, but they set out to do an experiment so that they can figure out which one is best. Next, we have the engineering design. The engineering design process attempts to solve a problem by creating something new. Depending on what kind of an engineer you are, you might be building something according to specs, and we'll talk about that later. So an example in an engineering design, the scientist would say, I have to invent a detergent. So in the first one, up here at the top, this one they're saying which is better, something that's already made, and they're comparing those. But here, an engineer may say that they have to invent a detergent, and here's what it has to have. It has to smell good. It has to be able to remove grass stains. It has to be able to remove ink. And I have to also be very careful that whatever chemicals I put into it are non-toxic to the environment. So, and then they go ahead and create something based on their criteria. All right, so what, part 2 here, what are the parts of the engineering design? Criteria. When you get into the workforce, if you are an engineer, somebody's going to give you a project to do. Your boss will give you a project to do. And it is the set of measurable standards or specifications that a design must meet. So your boss is going to say to you something like, okay, I want you to build a car that has 5 wheels and no roof. Of course, they'd have a reason for this. I don't know. Maybe this is for, I don't know, SpaceX is trying to create a vehicle that will work on Mars and it needs 5 wheels. Well, it probably would need a roof, but you get the idea. So the criteria is the things that your boss is telling you that your design must have. Constraints. These are like the limitations, not really the rules, but things that you're not allowed to do. Okay, so limitations or restrictions that the design must consider. So maybe you're not allowed to spend more than $1 million. Maybe it has to fit inside of a space shuttle. Maybe, what else do I, time. Maybe you have to have this done within 6 months, right? Those are the constraints. Criteria is what it must have, and the constraints are the things that kind of limit you on what you are able to do. So you might have a constraint that says you have only 1 week to build the car and you must use only plastic parts. Those would be constraints. One other important part of an engineering design is the prototype. And a prototype simply is a model that you make to test your design idea. And then you can make any observations, you can test it to see if it works. Maybe you find out that you built a 5-wheel car and the wheel, the 5th wheel that you put in is off, makes the vehicle off balance, and it would be better if you put it in the back rather than in the front, whatever. So the prototype is just a model that helps you figure out how you're going to build it. And at that point, you can make necessary adjustments if you need to. All right, so we have the engineering method here and we have the scientific method here. And when we learned about the scientific method, I was telling you about the acronym. And so I used some different words here. This one says question, but we use problem. People really hate termites and creepy cockroaches. So these are the same kinds of things. They may just be illustrated in a slightly different way. So scientific method, ask a question, do the research. You know, maybe you can already find out what makes tide better than gain. Figure out what your hypothesis is going to be. Then you're going to make an experiment. You're going to develop an experiment and create a test to see which one works better. You have to also decide, is your experiment actually working? Is it testing what you want it to do? Either it is. If it's not working, then you have to troubleshoot. Maybe you have to go back and redesign your experiment. If it is working and then you're getting some good results, then you have to analyze the data. You take a look at all the numbers and the observations that you make. In this case, it might not be just numbers. Remember, we said that numbers was quantitative data, but you might be also checking the stains, right? Did it get, to what degree did the stain get better? So that would be qualitative data. So, so you're going to analyze the data and you're going to make a conclusion as to which detergent works best. And then you have to decide if your hypothesis align with the results, or did it not align? Maybe if it didn't align, you're going to go back and change your hypothesis. That might mean that you have to change your experiment, change the variables that you used. But by the end, once you get through all of it, at the end you communicate your results. Okay, that's just a reminder of what we did the other day. So now let's take a look at the engineering method. Again, there's a problem. Your boss has a problem. We have to figure out how we are going to create a vehicle that is good for traveling on Mars. Again, do some background research. Wouldn't you need to know what the gravitational pull on Mars is? Maybe you need to know something about is there oxygen? Maybe you need to find out, you know, other things about the atmosphere. Maybe you have to find out like what the soil is like so that when you're driving on it, it's not going to sink. So you're going to need to do some background research. Then you need to determine what the criteria and constraints are. Again, this is when your boss says, okay, well, this vehicle has to be able to get to Mars on a space shuttle, right? That might be one of the criteria. It has to fit inside the rocket. And then it maybe also has to be able to do this or that. But we have to make sure that we don't go over budget. And here's our budget. And NASA wants to take this up to Mars at a certain, by Christmas 2023. And so you have to have it ready by then. So those are your constraints. Brainstorm and evaluate. So you're going to come up with a bunch of different ideas. Some ideas might be bizarre. They may not be a good idea, but you're going to come up with just a list of different ideas. You and your team, because engineering is a very collaborative kind of thing where you work together with the rest of your team. Nobody is individually responsible for everything. This is a team effort. So lots of brainstorming, evaluating the ideas, and choosing the best solution. Then you go ahead and you make your prototype, right? So then maybe you build a model of the car. You're probably drawing pictures to scale, figuring out where things are going to go. Then you're going to test it. So then you actually create one that you would probably use on Earth, and maybe you would put it into one of the zero gravity or simulate it to the same type of gravity that Mars has, and then you test it to see if it's going to work. Now, if your solution meets the requirement, then you can communicate the results. Okay, if they don't meet the requirements, like maybe partially or not at all, you will have to go back, because if your car is not suitable for driving on Mars, you're not going to waste anybody's money launching a rocket and sending it up there, right? You've got to make sure that if you spend that much money getting it up there, that it's going to work, right? So you may have to go back to the brainstorming stage and come up with different solutions, and again, a new prototype, until you have met all of the requirements and you can communicate your results. All right. This was just a short bit of notes for you guys today. So by the end of these notes, make sure that you are able to compare and contrast the difference between scientific method and the engineering process. Be able to determine the difference between a criteria and the constraints of a project, and also be able to explain what the purpose of a prototype is. There you go. Thanks for joining me today.